Alright folks, tons of stuff to cover. Tons of stuff, including this giant coronal hole facing right toward the Earth. It's in a T-shape, not to be confused with a Mr. T-shape. Also, we're going to talk about this magnetosphere spike that happened around 8:09 UTC, translating into a straight-up global pulse. Here's some more views of the sun. You see there's nothing going on in the colorized magnetogram. There you go. There's the last about 9 hours of solar activity in colorized magnetogram, and there is not a lot happening. Very low levels of solar activity despite a coronal hole wind stream, and we're expecting another one in about 3 days from that Earth-facing coronal hole. More views in a moment. But first, let's talk about supporting our channel on Patreon. Something you should greatly consider doing at the $10 level. Also, thanks donors who prefer to anonymously donate with no extra overhead via PayPal. Links in the description to that. Also, to the Hemp Lucid Spaced Out campaign, specifically formulated for our spaced out viewers. If you're buying CBDs, please buy them via our links, as there are a whole bunch of products out there, as well as some sales going on. Perhaps check out the 1,000 milligram 30% off. Let's go back to solar data. We see the phi angle's been all over the place for the past 24 hours. BTBZ is fairly convergent right now. And while we have a very low solar wind density, we have a very high solar wind speed, at least for the most recent solar minimum style conditions. It's remaining elevated at around 500 kilometers per second, which is pretty quick. But that should be ramping down soon, as that coronal hole wind stream should be slowly coming to an end here. Probably only several more hours of that, maybe 6-8 more hours of that. 10.7 centimeter radio flux, back down to 66 again. Solar minimum conditions, folks. That line for the rest of the year is going to be practically flatlined at the first hash mark there above 60. So while above predicted values, not much above predicted values. Moving on. We're not going to do anything with transients. Here's the spike we talked about. And let's look at the density, as there was a density spike. An odd density spike. Play that from the beginning to get your 4 hours of magnetosphere data. And here's the pressure. You can see just after 8 o'clock. And there's an apparent delay between this pulse in the magnetosphere space-wise versus the pulse in the magnetosphere Earth-wise. And we'll show you in the Geospace Magnetosphere movie the ground magnetic perturbations in a moment. And I'm going to rock that back once. 7 o'clock, there's 8 o'clock. And there are those anomalous spikes. It was pretty funky there, folks. That's a pretty odd one. No explanation for that, but we are going to talk about the space weather modeling framework before we move on here for a quick second, and we'll leave links to the extra pages that we feature. So, talking about the space weather modeling framework, there is a lot of stuff that goes into it, folks. And I mean, as you can see here, everything from gravity waves to 10.7 centimeter radio flux to inner magnetosphere to ionospheric electrodynamics. There's a lot of stuff that goes into it. So looking at the the solar corona and magnetosphere and so on. It's pretty complex to get these models, and they're quite modern in terms of your ability to look at such things. So anyway, we'll leave links to this page. You can read all about it. It's explaining some of the relationships, although it's not going to tell you the way the code is written. It's in Fortran and Perl. So here's part of that same spike here. This is 806 UTC. You see there's a bit of a delay on this, and I'm sure that is based on ground-based magnetometers. Again, read all about it in the Space Weather Modeling Framework description. There are a series of different links that you'll be able to see in there, so you can understand at least what systems are used to calculate the models. KP index has been pegged at only 2. It never even got to 4. Everybody was expecting a higher KP index than this. So if some spikes came in all of a sudden, that wouldn't be too surprising in terms of KP index, but it would be in terms of the way the coronal hole wind stream is playing out overall. Look at some cosmic ray monitors here. Here's Athens. We just saw a fairly precipitous uptick there across most of the range over the past 24 hours, really the past 6 hours. We'll also look at Apatity and Barentsburg. There are those two monitors. Here's Mexico City. Nothing too special there. And here's Moscow, which always seems to have a bit of a larger range than the other monitors. Please leave a comment if you think that's because Vladimir Putin is putting polonium-210 in the neutron monitors. Finally, here's Oulu, Finland. Nothing too extravagant there. And we'll do DOMC Antarctica. And we'll sack DOMB Antarctica since it has not been returning data for quite a while. We did see a spike in the ionosphere here around 3:30 UT. Let's play the whole thing here. Right there you see a sudden charging of the ionosphere. Nothing particularly extravagant. Here's the latest image. And it's looking pretty normal, a little discharged on the sun side. Regular viewers, I'm sure, are aware. GOES X-ray flux totally flatlined. And thanks, new subscribers. GOES electron flux is experiencing a dip with the high-speed solar wind stream, the coronal hole wind stream, that is. And you would expect to see that. It's what you would call proton light. A bit of a slight electron shortage, not an extreme one. And we've seen some real extreme ones during the solar minimum, as well as extreme electron storms during this solar minimum. Again, there's a lot of different variables associated with solar activity. Don't assume the only ones are solar wind and sunspots. There are a lot of different factors in what the sun's doing. The most important being, of course, the solar polar fields. In any case, here's where planets are located right now. There's where they'll be in 1 week. Crescent waxing, moon, and a big pileup of conjunctive planets going on. In fact, here's the LASGO C3, and there you can see Mercury swinging into view there. So, quite a nice view. You've got Mercury, Mars, and Venus all in the LASGO C3 image. GOES magnetometer is showing continued spikiness, as we would expect. When that coronal hole wind stream ceases, this should smooth out. Here's the GONG2 data. This one being 1 hour and 9 minutes old. And we are welcome to the North Pole associated portion of the heliospheric current sheet. That green portion is associated with the solar polar North Pole field. And that should be fairly smooth times there until the next polarity crossing. Probably at least 3 days, maybe even 4, until anything changes, although we do see a little battle over the fields going on right here in the most current image. And here's the view stereo A-wise, looking at the far side of the sun, about 1/3 of the way behind the Earth in terms of orbit. And not a lot of activity going on either there, folks. Our most recent earthquake is this one right here near Anchorage, Alaska. And yeah, that one located right near that inlet. Under a glacier, it looks like, folks. Or was it a giant frac quake? Oh, geez. It's a pretty big quake. It's a 4.1, anyway. Anyway, let's zoom out and go back to 24 hours worth of 4+ magnitude quakes, like this 198 kilometer deep one at a 4.3 magnitude in Afghanistan. Here's a 4.8 at Indonesia, a 4.6 at Fiji, and that one is at 535 kilometers. By the way, that's a deep quake in Afghanistan too there. So heads up, both of those quases for a large earthquake. Watch your low pressure systems. Here's another 500+ kilometer deep quake near Fiji. That one a little farther northeast. 4.9 at Mariana Islands. Here's a 4.7 at El Salvador. Largest quake of the past 24 hours is 6.6 in the South Sandwich Islands in the middle of nowhere. At least not a deep quake. Here we see a 4.4 at Venezuela. 4.1 at Alaska. That one is a deep quake. Heads up, Alaskans. I only had to click on it 19 times for it to work. No big deal. Anyway, that deep quake there looks like it's located under an inlet also. Some hilly areas there. Anyway, that's a location of that. Moving on and fixing the map. I'm sure if you've navigated this site, folks, you are familiar with my plight. Oh, yeah. All right, so the last couple quakes we've seen in the last 24 are 4.2 at Mexico, 4.6 at Papua New Guinea. This one only a couple hours ago. That one at 96 kilometers depth. 4.1 at Anchorage. Again, that one only a couple hours ago. 5.6 at the South Sandwich Islands, and another 5.6 at the South Sandwich Islands. Check out the swarm. Let's zoom in on that area. Right on a 3-way plate boundary corner. Some drifting quakes there. 3 right in succession. So they look like aftershocks on the plate boundary and on the other side of the plate boundary, though. Interesting. Let's talk Shivaluch. Jeez. Oh, Shivaluch. So there's Shivaluch. We're looking at the windy.com sulfur dioxide map. Let me zoom out on that so I can show you where that volcano is located. Still producing a sulfur dioxide cloud as volcano discovery retracts the story about the 70,000-foot ash plume. Check this out. Their new stance on the 70,000-foot stratospheric aerosol and volcanic ash plume injection, aka a global cooling effect, now stating that it didn't happen. To quote Volcano Discovery, The recently reported eruption on 25 August, alerting of an ash plume as high as 70,000 feet, did not take place. Now, I know there's been a lot of Himawari data being shown, which I was not out there trying to corroborate the fact that it was 70,000 or 60,000 or any thousands of feet. Now, according to Volcano Discovery, it was an erroneous alert. The ash column was only roughly 23,000 feet of altitude, off by a factor of 300%. off by 300%, a factor of 3. So, please leave a comment if you have an opinion on this, as I'm sure many viewers will. Here's a rundown of the volcanoes on the list for today. Shivaluch producing it's just a blurb about the thing I just covered. Also, Sanjang Api in Indonesia there, producing a 10,000-foot ash plume. Dakono, 6,000-foot ash plume. Popocatépetl exploding like Dakono, producing a 21,000-foot ash plume. And Sabancaya, an uptick there, adding about a mile height to its ash plume, now 30,000 feet, as explosive activity continues. And more things like carbonyl sulfide are injected into the atmosphere, which is great for plants and bad for cold temperatures. Although it does make places greener, it does also make it rain more, increases the Earth's albedo effect through cloud nucleation, and cools the planet. Check out the jets in the west. They are all over the place, at some locations utterly backwards. And if you're calling that meridional jet stream flow, well, I salute you, as you probably know what that means, but this isn't quite flowish enough to be meridional jet stream flow. I think it's about 2/3 jet stream and 1/3 convective forces at this point, unlike earlier in the season, when it was like 75% convective forces and 30% and 25% jet stream flow. Here's the southern hemisphere, and it's pretty perturbed, as there is a high altitude, high pressure 10 hectopascal low pressure system going on right south of Australia. So that has a real effect on the jet stream folds, folks. Again, that's the 10 hectopascals. This is probably what the planet would look like if you looked at it from a different solar system. Anyway, let's go back to the jets. This is flight level 25,000. And there's the southern jet system. Quite meridional and becoming much more convective than it was throughout the southern hemisphere winter. It was extremely high-speed concentrated jet stream all winter. And there's a bit of AccuWeather.com's U.S. Doppler radar. Leave the timestamps on there. There we go. And we see a bunch of pretty choppy little thunderstorms there off of the coast of New Jersey. Looks like a good day for surfing on the Jersey coast if you have the right kind of offshore winds, obviously, which you very well may have with all of that stormy weather just off of the coast. Otherwise, pretty much a respite, no super severe weather, although there is a significant convergence line. We'll look at it. And there you have that. As this dry mass of air is compressing the babbling brook of this atmospheric river that's going on. And we'll animate the whole map here real quick. And there's the situation water vapor-wise over the U.S. Tropical system forming there east of Georgia. I would note also the jet stream dip. It's going to be injecting very cold air into places like Minnesota, Wisconsin, and Michigan. Let's zoom in on that also, as that is an interesting scenario. That dry mass of air holding back all of that very cold, moist air coming out of Canada. It's going to be a chilly and choppy day to be sailing on Lake Superior. Hey, thanks for tuning in, folks. If you tune in a little longer, you may even find some bonus sections. So don't go anywhere. Unless you've got somewhere to go, then by all means, go wherever it is you need to go. Let's talk about streaky auroras. Don't let it cause streaks in your underwear. This NASA article showing some interesting phenomenon. Let's let it play. Showing some interesting phenomenon here. You can see actually where the Van Allen belts would be expected to be located. So it's a great little animation here. We've got links to this in the description. So check this out if you want to check it out for yourself. You've got the diffuse auroras versus the discrete auroras. Good stuff. And it's not thumbnailing very well for us, but an interesting article about things like the Van Allen belts. As we know, many of our viewers are very interested in understanding things like the layers, like the troposphere and the mesosphere and the stratosphere and so on. So have yourself a read. And have yourself a bonus section. And have yourself a delightful day. Here's the sun, our local yellow dwarf at 94 angstroms. This is 8 hours and 45 minutes worth of activity. That coronal hole is so well defined that it's clearly visible even in this wavelength, which is not always the case with coronal holes. So I invite you to stare at the sun, yes, and stay tuned for another video coming out in about an hour. Remember, when you're staring at the sun, don't drink it. If you drink, stare at the sun anyway. Just don't drive. And since it'll never be now again, may the solar wind be at your back and the atherosclerosis absent from your veins.